Hi guys, welcome to Wisdom Academy YouTube channel. Today we are going to see elementary operations of matrix. Okay, there are 6 operations. In that 6 operations, 3 depends on rows and 3 depends on columns. So I am giving you both together here. So the interchange of any 2 rows or two columns, that is, if I am having a matrix 1, 2, 3, 4, I can able to interchange this row by representing R1 to R2. Then now the matrix will be 3, 4, 1, 2. So this is the one of the basic elementary operation, that is interchanging of rows and columns. Okay, so I did it with rows. Once again I will show how to do it with columns. If I want to do it in columns, if I am taking a matrix, I am going to change the columns, then I will write C1 interchanged with C2, and it is going to be like this. Then so 2, 4, 1, 3. Okay, now what I did, this column is interchanged, these columns is interchanged here, and this one went there. So this is known as interchanging of 2 rows or columns. So 2 operations we finished here, and the third operation is the multiplication of the elements of any row or column by any non-zero number. If I am having a row, take a 3 by 3 matrix, 1, 2, 3, 4, 3, 2, 2, 1, 1. If I am having a matrix like this, then I can represent this by R1, R2, R3, right? Now I want to multiply number 2 by R3 for any purpose. You will know why we are multiplying any row by any number, that I will say in next slides. If R3 is equal to, I can write like this, that is 3 R3. I can write like this. That is what I am going to do. I am going to multiply this row by a number 3. It can be any number, even I can put 1 by 3 or 3, right? I can put 1 by 2, whatever, minus 1 by 2, whatever. So any non-zero numbers, I should not multiply with 0. Any non-zero numbers I can able to multiply with any row. Similarly, I can do it for column. When I am doing for column, I will represent like this. R1 is going to change as 1 by 2 C1, that is C1 is interchange, it's going to be changed as 1 by 2 C1. So what I will do, I will change this column with 1 by 2, 4 by 2 is 2, 2 by 2 is 1. I can represent like this. So this is what say a fourth elementary operation, that is one is depending on the row, another one is depending on the column. So this is third and this is fourth. Okay, so now up to now 4 operations we have seen, elementary operations. That is, first is we can interchange 2 rows or columns, that is first elementary operation, second elementary operation, and third elementary operation is I can multiply a number with any other row or column, that is third and fourth operation. And my fifth operation is this one. If I am having a row like this, if I am taking a matrix like this, 4, 2, like this I am having, I can write like this, R2 is going to be R2 plus 2R1. I can write like this. That is, I can even add, at the same time I can multiply any row. I can put here also, nothing wrong in that. That is, R2 will be R2, what is R2 here? 4 and 2. And it's going to be added with 2 into R1. So R1 is 1 and 2. So it is into 2, so it is going to be 2 and 4, and I am going to add it, so it is going to be 6 and 6. So then my matrix will change into 1, 2, 6, 6. So this is fifth operation. If I do the same thing in row, column, then it will come like. So these are the options. I am showing the examples. You can use any number, you can use whatever column, row we want. So these are the examples I am showing to you. These are the 6 simple elementary operations that we are going to use in the matrix. So for what is the use of this is, we can using this we can able to find the inverse of your matrix. Okay, once again I will repeat these 3 points. That is, if a matrix is given to you, I can interchange rows, I can interchange columns. We are going to say it as what is this? Elementary operation. And what the second thing is saying is, I can multiply any row with any number. Okay, I can multiply, or it's the same thing, I can multiply a column with any number, with any non-zero number, that is important here. This R3 can be written as R1 any row or any column with some multiplication. I can combine these two, right? I can combine like this two. So nothing wrong in this. And similarly I can do it this for columns also. Like this we can. So these are the 6 important operations. These are the examples I wrote. Whatever operation we need, we can do. So whatever numbers we want to multiply, we can multiply. Whatever row we want to select, we can select. Whatever the column we have to select, we can select. Nothing rules like that. But we want to do it for some particular aim. That aim is to find the inverse of the matrix. So the next we are going to see that. Okay. Now find by using the elementary operation, find the inverse of the matrix. They given A is equal to. So we can write like this. That is A into A inverse equal to I. Then if this inverse goes here, it will be like A equal to I into A, right? I can write like this. Okay, so I am going to represent like this now. That is A is here 1 2 2 minus 1 is going to be equal to, what is I? 1 0 0 1 into 1 2 2 minus 1. My basic idea is, if I make this matrix into I, if I make this matrix into I by using my elementary operation, then this matrix also will change into some other matrix, not an identity matrix, it will change to some other matrix. Listen carefully guys, if I am changing it's the equation, right? A equal to IA. So this is the equation. So I am going to do the elementary operation for this whole matrices, all 3 matrices I am going to do, and I am trying to make this matrix into I matrix. So what happens, this matrix also evolve to the current operations, and this matrix will become A inverse. Why? Because A into A inverse will be my I. So I know A is equal to I into A. So I am going to write my A here, and I know my I am going to put A as it is. Now what I am going to do, I am going to try using the elementary operations A into identity matrix. So what I am going, so I want to make this elements into 0, these 2 elements into 0, and these 2 elements has to be 1. So this is my aim. I am going to do that kind. So using for to make this possible, I am going to use all my 6 operations. So first what I am going to do is, to make this 0, what I will do, R2 is equal to R2 minus 2R1. Shall I write like this? So what will happen? This 2 will be minus 2 into R1. So I will get 0. So I am going to do, but same thing I am going to continue for all the matrices. So what I will get here will be 1 2 0. Here it is going to be minus 5. Okay. So same operation I am doing for this identity matrix also. So this identity matrix will evolve into 1 0 minus 2 1. Okay. So what I am going to do next is, this thing I has to make it into 1, right? This element I has to make to 1. So what I am going to do, R2 is equal to 1 by, so it is going to be minus, so minus 1 by 5 R2. So now this will evolve into 1 2 0 1 is equal to the same operation here, R2 will be divided by 5. Did you understand? So now the only operation, now only mission that is waiting is, we want to make this also to be 0. So to make it 0, what I can use, I can multiply these two and I can write like this, right? R1 can be written as R1 minus 2R2. Shall I write like this? So what will happen? So I will get like this, 1 0 0 1 is equal to 1 by 5 2 by 5 2 by 5 minus 1 by 5 into A. Now consider our this thing, A into A inverse will give me I, right? Now this is A and this is some matrix and is giving identity. Then what this matrix is said to be? A inverse, right? So my A inverse of this matrix is going to be 1 by 5, 2 by 5, 2 by 5 minus 1 by 5. So this is the inverse of A matrix. Okay, I will repeat the same thing once again. So if I am in A matrix A, I know I want to find the inverse of this matrix. So A is equal to I into A. So what I will do, I want to represent as it is. So A will represent, I will represent. A as it is I will keep for the easy thing. So what I will do, I want to make these 2 into 0 and these 2 element into 1. For that I will use the elementary operation. To make this to 0, what I can use the other rows and other columns numbers. So I can multiply this first row and minus by 2. Or you can even use the columns, nothing wrong in that. We can even use the columns, and somehow I want to make this matrix to be an identity matrix. What are all the operation I am going to do for this matrix, I want to follow this for identity matrix also. At last I will get a matrix which is multiplied with the A, which will give me identity matrix. This matrix I will say it as an A inverse. Okay.